In general or in here? Yes.
General. I ran out of ideas.
Oh, it does make it for an interesting day. I've done that. Manual mode is what this is. All right, so let's look at these. Neither one of these were particularly recent things we've done, so these are both kind of from the deep recesses storage in the brain. When we have a fraction like this, what can we do to simplify it? More specific than divide by 2, because that is what this means. What will we get when we divide by 2?
X plus 3.
Mm-hmm. Yeah. We're going to wind up at x plus 3. I'm going to show us an in-between step. One way to do it is to split it apart, uncombine our fractions, so that we get our 2x over 2 plus 6 over 2. Uncombine your fractions, so then you can simplify them individually. That is absolutely one way to think about it. You could also do the 2x divided by 2, 6 divided by 2. Another way to do it. There's probably other ways to think it, but I feel like those are the two most common ways. So simplifying by splitting up our fractions. Whenever we have addition on the top, we can do that. If we have addition in the denominator, we cannot do it the other way. So then let's look at this long division over here. Holy cow, has it been a long time since we did some long division. What do we do for long division? How do I start? How many times does 3 go into 4? We're looking at this first piece here and this first piece here. How many times does 3 go into 4? Once. We put that up on top. We take our 1 times the 3 and we put it underneath. And then what do we do?
Subtract.
Subtract. So 4 minus 3 gives us 1. And then I'm going to drop the 9. It just comes on down. That's round 1 on the long division. Then we get to do the whole process again, but instead of looking at the 4, we're going to look at this 19. How many times does 3 go into 19? 6. Because 6 times 3 gives us 18. And then again, we're going to do a little subtraction. We're going to subtract between these two. It's going to give us a 1. And we're going to drop down the 3. What's going to be next? What's going to go here? 4. Because 3 goes into 13 4 times, because 4 times 3 gives us 12.
Interruption. Good morning. Teachers and we the students, testing resumes first period this morning. Teachers, please check the testing roster spreadsheet tabs for your name alphabetically in column A to see if you have any students
What the heck happened to my curtain?
during the first period. Testing students received an email last night indicating that
Somebody
testing
tied
room
a knot
location.
around it. What the heck?
Testing students are
Heck.
dismissed and should move quickly to their testing rooms. Thank you.
I will double check my desk, but I don't know that I don't think we have any testers today. All right. So if we wanted to have this as a decimal, I could just keep going, put a 0.0, drop it, and continue on. But I don't want to do that. I want to put it as a fraction remainder because I'm out of values up here. So this is what we have left. When we first started doing long division, we'd say we had a remainder of 1. That's one way of putting it. The other way we can put this is that I have 1 out of, how many pieces did we need to have? 3. 1/3. So 493 divided by 3 is 164 1/3. you leaving today? Just double checking. Okay. Questions on that? Mister? Yes. Okay. So I wonder why we just did a problem that has long division as, high schoolers. Especially when we've been working with polynomials. And we've taken them and we've done some adding. And we've done some subtracting. And we've done some multiplying. I wonder what we're doing today. It's dividing. We're going to start with dividing our polynomials. And we're going to see them written a few ways. Our first one here is dividing by a monomial. So I have a polynomial, and we're dividing by a monomial. Whenever I have one written like this where it's sideways and we're using the blank fraction symbol or the division symbol, because it's really just a fraction with a placeholder kind of one. Something over something. We know that. It's division. So I'm going to write it as a fraction again. Okay. Abigail, I think you cursed me because now my pop socket just... It's like you're just causing chaos. My pop socket just spat out the little lid for it. So I have this big piece here, and I'm trying to divide it by this guy. So I'm going to write this as a fraction. So we have our 24a to the 4th plus 18a squared minus 30a. And we're dividing it by 6a. This is a kind of complicated piece and a kind of simple piece. It looks really, really similar. Kind of a very similar vibe to maybe this guy. Oh, snap. This is the process we're going to use. So we're going to take a fraction like this. If we are dividing by a monomial, if there's no adding or subtracting in this piece, cut it into pieces. So I'm going to split it apart any place we have an addition or subtraction symbol, here and here. So we're going to write this as, I need to zoom in so we can write better, 24a to the 4th over 6a plus 18a squared over 6a minus 30a over 6a. So we put it as a fraction. We slice it into pieces. And then we're going to look at each piece individually. So we're not going to try and do all of them at the same time. Make your brain focus on a single piece at a time. I'm just getting to my place before I do so. There we go. So what we're going to do is we're going to look at this chunk first and simplify this. 24a to the 4th over 6a. What's 24 divided by 6?
4.
What's a to the 4th over a?
3.
A to the 3rd. Yeah.
Cubed.
Cubed to the 3rd, power of 3, all mean the same thing. So we take our 24a to the 4th divided by 6a, and this piece simplifies down to be our 4a cubed. Oh. Thank you, dear. Hey, man. Our plus sign's going to drop down. Thank you, sir. And then we're going to do the same thing, but just with this chunk. 18a squared over 6a. 18 divided by 6? 3. A squared over a.
A.
And again, you can think of it as subtracting our exponents, because this is a to the first, so 2 minus 1, just like this one was 4 minus 1. Or you can think of it as a times a over a, and one of them cancels out. However your brain chooses to do that, we should wind up with an a here. And then we have our minus, what's the last one going to be?
5.
30 divided by 6 is 5. A over a cancels out. We have our minus 30a over 6a. So we're going to keep the minus over here. If you want to put it as plus negative 30, that works, but it's doing a lot. It's easier to go this way. Oops, sorry, didn't mean to do that. Okay, so whenever we have a monomial, a single thing here that we're dividing by, we're just going to cut them apart. We're going to break them apart and do it that way. Questions on the first one? I'll practice it again because I know it's a little awkward and weird. Sometimes you will see problems written just like this, where we will have them in a single line. Sometimes we will put them in fractions. We will see division written both ways. We will see them written as a sideways like this, or we will see them written as fractions like these. This is the other way we will see monomial division problems. We have 25x to the fourth plus 15x cubed minus 10x squared plus 5x divided by 5x. And we are again dividing by a monomial, dividing by one thing. There's no adding or subtracting in what we're dividing by. So if we have no adding or subtracting in what we're dividing by, we're going to cut it up into pieces. Cut my math into pieces. All right, so every place I have an addition or subtraction symbol, that's where we break it. So we're going to have our 25x to the fourth over 5x. And we're going to cut it there. Plus 15x cubed over 5x minus 10x squared over 5x plus 5x over 5x. So break them apart. And then we just deal with each piece individually. So just look at one guy at a time. What are we going to get on this first piece, this purple piece? Our 25x to the fourth over 5x. 5. X to the third. X cubed, x to the 3. Absolutely fine. Gorgeous. How about for our blue one here? 15x cubed over 5x. What's 15 divided by 5? 3. X cubed divided by x? X squared. Remember that that's x cubed is 1, 2, 3 x's being multiplied together over x. So one set cancels out and we're left with 2 x's. That's what we're doing when we're looking at those exponents here. Then we've got our minus sign. I've got 10x squared over 5x. What are we going to have? 2x. Good. And our last one, 5x over 5x. 1. It does not just disappear. It is not gone. It is not 0. It simplifies down because they're exactly the same thing. 5 over 5. It's the same thing as 1. Not 0. Honestly, that's the most common mistake I see. Is that when it cancels out, we're just like, nope, we don't got to put it because it's not there anymore. Okay, so dividing polynomials by monomials, not too bad. Not too bad. It's just simplifying fractions. There's a whole lot of phone work happening in the back. Oh my goodness. Maybe we should do notebook work instead of phone work. Might be helpful. Because then we're going to do was gonna say not just in the back, but just say it's most prevalent. So then we're gonna see what happens if we don't have a monomial as what we're dividing by. So dividing by a monomial, really not too bad.
I'm scared.
We did a whole nother thing in the bell work, didn't we though? I wonder if it was relevant to what we're doing today.
It's always relevant.
Most of the time. So, when I have a polynomial that we are dividing by a not monomial, typically it'll be a binomial, something that looks like this. We can't do it the same way. I can't put them into little baby fractions because there's too many pieces here. So what we're going to need to do is long division. I'm going to show you how. It's going to show up again. So we're going to use long division here. That's why we did it in the bell work, so you could remember that mechanism with something significantly more familiar. So we've got x squared minus 5x minus 36, and we're dividing it by x plus 4. When we are setting up long division, that's when we have our little division house. And I'll put it right like this. I'm going to do a big one. Because the thing in the front, that goes inside. My x squared, I didn't do too far, minus 5x minus 36. And what we're dividing by goes outside, that x plus 4. So we set it up like this. I don't like those being the same color. There we go. I just did not like those matching. So this guy goes out in front. When we're looking to start our division, we still are going to compare the first piece with the first piece. I'm going to look at how my x squared and my x interact. At this point, we're ignoring the 4. When we have variables, it's sometimes a little trickier to wrap our brains around how many times does x go into x squared. Another way to think of it is a little baby fraction. If I did x squared divided by x, what would we get? What is x squared divided by x?
X.
X. That's what goes up here. So you can either think of how many times does this go into here, what would this need to be multiplied by to get here. You can do it as a little baby fraction to figure out what goes here. There's lots of ways to do it, but I feel like this way tends to work for a lot of people. If I take the first term and divide it by the first term, that tells me the top. Once we have found the top piece, that's what we take and we multiply by what's in front. And we hit the whole thing. Now the 4 comes into play. So we're going to take x times x plus 4. X times x gives me x squared. X times 4 gives me plus 4x. All right? Yeah. In long division, when we get to this piece here, what operation do we use? We subtract. I need to subtract both of them. That is the most common mistake we make, is that we subtract the first one and then we add the second one. So x squared minus x squared gives me 0x squared. This first term should always be a 0. It's always going to cancel out. If it doesn't, something went wrong. Then we have our minus 5x minus 4x. Minus 5 minus 4.
So would it be 9x? Negative 9x?
Negative 9. It's I owe you $5 and I'm borrowing $4 more. So it's negative 9x. And then our next piece is going to drop down. Round 1 done. Let's go for round 2. Where I take my first term. I gotta get a color that's not been used and is still visible. Oh, pink. I've done that one. I take my first term and my first term, and I see how many times does x go into minus 9x, or what multiplies by x to make minus 9x, or you set it up as a baby fraction. Minus 9x over x. No matter which way you think it in your brain, what do we get if I take, what needs to multiply by x to make minus 9x? X times what is minus 9x?
Negative 9.
Negative 9. Or minus 9x over x. My x's cancel out, and we have minus 9. So the piece that's going to go on the top is a minus 9. We'll practice it several times because I know it's super awkward. We're going to take our minus 9 times the whole piece over here. I have our minus 9x. 9 times 4 is 36. And then we are subtracting the whole piece. So we have minus 9 minus negative 9. So it becomes minus 9 plus 9. And we have 0 x's. Again, that first term should always cancel out. Negative 36 minus negative 36, we get 0. What this means here is we have no remainder. If we have no zero, nothing left on the bottom and nothing left to drop down, there's no remainder, which is great. We will, for the most part, have no remainder. I don't know that we... Okay, so what this means and what this is showing us is that this piece, if we multiply it by this piece, we get exactly this. So a way to write this as a solution is that we have our original piece, our x squared minus 5x minus 36 is the same thing as that x plus 4 that we divided by times what we got on the top, x minus 9. So when we're doing this in quadratics, it's kind of like an overcomplicated way of factoring. We're not only going to do it with x squareds because it's just doing too much. Because we could have factored this one. We just didn't. So it's obnoxious and long and annoying and weird. And I get that. That's why we're going to practice this several times. Okay. Questions on this first one other than why? Why is kind of the general question on this, because I know it's doing too much. But it's one of those things. We got to do it. Okay. Here's our next one. He's a little bit. We've got our 3x cubed minus 2x squared minus 75x plus 50, and we're dividing that by 3x minus 2. Bless you. So we're going to set this up as long division because we definitely cannot set this up in baby fractions and divide because this has adding or subtracting in it. So when we build our long division, why is there like a blank space in the line here? That's weird. That's okay. We put the first piece inside, my 3x cubed minus 2x squared minus 75x plus 50. And we're going to divide it by our 3x minus 2. So step 1 is to set this piece up, set up our little house. questions on the setting up of the house part? Okay. So I'm just going to word it slightly different. We look at the first piece and the first piece. So we're going to look at our 3x cubed and our 3x. What would I need to multiply 3x by to make 3x cubed? 3x times what gives me 3x cubed?
X squared.
So that's one way to think it. If the little baby fractions did not work with you yet on the last one, you can do it that way. This piece times what gives me this piece. Or you can do 3x cubed over 3x and see what's left over. It's doing the same thing. It's just a different way to do it in your brain. Okay? So now we're going to take our x squared times the whole chunk in front. So I'm going to take this guy times this whole piece here. So x squared times 3x gives us 3x cubed. X squared times minus 2 gives us minus 2x squared. Cool on that part? Then we subtract everybody. So we need to make sure we subtract our 3x cubed and subtract this piece. So that's super important that we subtract. 3x cubed minus 3x cubed, we have 0x cubes. That's what we expect to happen. If this first piece does not eliminate out, something went wrong. Stop and check in. Then we have minus 2x squared minus negative 2x squared. I get a 0 on this one too. 0x squareds. So this one also cancels out. So then what we do is we're just going to keep on moving. I'm going to come over here and we're just going to drop down these guys. I'm going to use green still. I mean, you don't have to, but I recommend it. Since we have 2 pieces over here, we need to make sure we got 2 pieces over here. Just since we don't have anything else coming on. Plus 50. I'm going to drop them both. You want to make sure you have in your piece that we're going to subtract from the same number of pieces this has. So this has 1, 2 pieces. I want to make sure we've got 1, 2 pieces so we can subtract everybody. And then we get to do round 2. So we want to know 3x times what is going to give us negative 75x? Negative 25 minus 25. Then we're going to take that minus 25 times these pieces, both of them. 3x times minus 25 gives us minus 75x. Minus 2 times minus 25 is a positive 50. And once again, we're going to come through and we're going to subtract everybody. Minus 75x minus negative 75x. Or minus negative, that's like having a plus here. So negative 75 plus 75, we get 0 x's, which is great. We love that. And then we have 50 minus 50. 0. So we could write this polynomial of 3x cubed minus 2x squared minus 75x plus 50 as a product of 3x minus 2 times x squared minus 25. Those two things equal each other. Could we do anything more to simplify this? How about this guy?
Wait. It's for
Super close, perfect squares,
squares.
right? It's the difference of squares. It's one of those special patterns we talked about last semester, where we have something that's a perfect square in front and something that's a perfect square in the back, and it's being subtracted. So we could factor this. Again, you can use the box if you want to. You can use our other factoring tools. But this one we can factor because it's a difference of squares. So we're going to fully factor this guidance lesson. So this thing is a difference of squares. I'm just going to draw a square because I don't have space for the word square. Difference of squares. How do I write the difference of squares pattern? How would we write that? It makes two pieces. Mm-hmm. Yep, x is in the front because that's what squares to make x squared. What squares to make 25? 5. One factor gets a minus and one factor gets a plus. So 3x minus 2 times that difference of squares equals that whole polynomial. That looks like an 11. I don't want that. Okay, so if we have something we can factor, I encourage us to look at that. Sometimes we'll ask you to do that, sometimes we won't. Long division is long. It's part of the name. It's one of those things. They take up space. Okay? So, that's I am going to give you the last homework of that chapter. And you guys can do everything on the front. We will do the things on the back on Monday. Tuesday. We won't be here Monday. Monday is Martin Luther King Day.
Oh, yeah.
Absolutely. Okay, so I'm going to pass these out. Okay, so we will do more division stuff on Monday. It's not going to be harder, but I am going to show you a way that we can do sometimes before that. To make long division not quite so, oh my gosh, that's too dang long. Okay, because sometimes these get beastly long. That's how they do it, how it goes, is why long division is called long division. It is in fact long. Yes, dear. I think that's great. Do them together. Yep, yes, dear. Perfection, yes. Absolutely perfection. All right, so today, turn in your homework 4.3. Turn in your bell work week 2. And then this one will be due, oh, that's right, it should be, let me see. Yeah, Thursday, that is right. Because we're going to do a new thing on Monday, and we'll practice them both we're going to do a new thing on Tuesday, and then we'll practice them both again on Wednesday. So I want to make sure you guys have time, because long division is long, and I want to give you guys time. Okay? And especially because part C has like no space to write on, which is annoying on number 2. But it's there. Okay? So those are all the things. That's how far we're getting today. Those are all of our examples. So work through stuff. Ask questions if you got them. You guys have about 5 minutes until announcements. So yeah, do the thing.